A stone of mass 1 kilogram and weight 10 newton fell through the air. The air resistance acting on the stone is 2 newton. What's the acceleration of the stone? So we are going to find the net force. So the acceleration is going to be 8 meter per second square. A 15 kilogram block rests on a surface of negligible friction and is pulled by a string that's passed over a pulley of negligible mass and connected to a hanging 5 kilogram block. In terms of the acceleration due to gravity g, the acceleration of the speed is. If we look at the entire system as a wire, then the weight of the 5 kilogram block is the force that accelerates both the 5 kilogram block and the 15 kilogram block. In other words, the weight of 1 kilogram is accelerating the equivalent of 4 5 kilogram blocks, giving only 1 over 4 as much acceleration as the block would have if it were falling flatly. So this is same with 3 5 kilogram block, and this is gonna be the first 5 kilogram block. So the acceleration of speed is gonna be 1 over 4 g. A pendulum is dropped from a height of 4 meters. The speed of the pendulum at the lowest point in the swung is most nearly. So the potential energy is gonna be same with kinetic energy. So the speed is gonna be 9 meters per second. A ball drifted from a tower will strike the ground below in 3 seconds. If the ball is launched horizontally from the tower at a speed of 10 meters per second, how far horizontally from the base of the tower will the ball land on the level ground? So the time is going to be 3 seconds and velocity going to be 10 meters per second. The horizontal distance is going to be this, and we are going to apply these values. So the distance is going to be 30 meters. An object starts with a speed of 10 meters per second and accelerates at minus 2 meters per second square. How much time will pass until it comes to rest? How far does the object travel before coming to rest? So the velocity is going to be 10 meters per second and acceleration is going to be minus meter per second square. So firstly, for finding the answer of the first question, the final velocity is going to be 0, and we are going to apply this equation. So the time is going to be 5 seconds. And for finding the answer of the second question, we are going to apply this equation. And the distance the object traveled before coming to rest is going to be 25 meters. A mass M is hanging from 2 light strings. The tension in each string is. So the tension of the string is gonna be this. We are going to find this free body diagram, and this force of the y-axis. So the forces of x-axis is gonna be same. So we are going to apply this. So the tension force is gonna be this. A block of weight 180 Newton is pulled along a horizontal surface at a constant speed by a force of 8 Newton. The force acts at an angle of 30 degrees with the horizontal. What's the normal force by the surface on the block? What's the friction force acting between the block and the surface? What's the coefficient of friction between the block and the surface? So firstly, we are going to find the free body diagram. This is going to be the force applied, and this is going to be this. So we are going to find the answer of the first question. So the normal force is going to be 104 Newton. And we are going to find the force of friction, and this is same with the force of x-axis. So the friction force is going to be 70 Newton. And we are going to find the coefficient of friction, and So coefficient of friction is gonna be 0.5. So this is what we are finding. A 2 kilogram box is placed on a scale in an elevator. When the elevator is not moving, the reading on the scale is 20 Newton. When the elevator is accelerating upward and 20 meter per second square, the reading on the scale will be most nearly. So this is gonna be the elevator. And mass is going to 2 kilogram and the acceleration upward is gonna be 2 meter per second square. Also we are going to find the force. When the elevator is accelerating upward, the plus sign is used. So number force is gonna be 2 kilogram multiply 10 meter per second square plus 2 meter per second square. So the normal force is gonna be 24 Newton. A toy train undergoes 3 periods of constant speed. 6 seconds moving at 2 meters per second, 4 seconds standing still, and 10 seconds moving at 30 meters per second. The average speed of the train for this is 20 seconds and most nearly. In the time velocity graph, the area is distance. So the total distance is gonna be area. So we can find the 42 meter, and the average speed would then be 2.1 meter per second. On 0.2 kilogram disc sliding of a meter per second on a table with negligible friction strikes on 1 kilogram disc sliding at 22 meter per second in the same direction. After the collision, the 0.2 kilogram disc slides backward at 2 meter per second. What's the speed of the 1 kilogram disc after the collision? Use conservation of momentum. So this is the initial momentum, and this is gonna be the final momentum. So the speed is gonna be 4 meters per second.